I kid you not, when I first started working on this paper, I went to PubMed and I was trying to find, what else had been published out there on Alzheimer's. I could not find one other paper that had ever actually looked at this. I thought, wow, this is really cool. Like, we're going to have an opportunity to be the first group to actually publish what the Th1 to Th2 ratios look like in people with Alzheimer's disease. The people with Alzheimer's were so Th1 dominant. I mean, their scores were just off the chart. And then over that 12-month intervention, we looked at 6 ratios. 5 of the 6 actually started going back toward less Th1 dominance. And then the icing on the cake was that the going back, sort of rebalancing, if you will, was correlated with improved cognitive function. I mean, it was just a beautiful paper. So that was the 4th paper. The 2 in between were related to brain-derived neurotrophic factor, and we correlated that with different markers of cognitive function in one paper and immune function in another. We were trying to find a little bit more mechanistic explanation for why we showed these improvements. Those 2 papers, in my opinion, weren't as exciting as the first one and now the 4th one. The 2 papers we published in the MS study, they again showed very similar findings, although not so much focused on cognitive function. One of the papers we looked at showed a dramatic decrease in infection. These polysaccharides also happen to be very anti-infectious, so very counteractive against virus, bacteria, fungus, other types of pathogens. But the people with MS went from like 8 infections at baseline down to 2.5 at 12 months. And one of the things I learned along the way in running that trial was that people with MS don't actually die from neurodegeneration. They ultimately die from infection. So to be able to knock out that infection was just really, really nice.